good about the microphone. Yes, we're here. We're gonna do this today. By the way, I don't see the Seribot stroke. I know it was there, but chat loaded after that. So now I don't know about it. Anyway, I think music is still on. Let's put it 100% here. Yeah, it lags a bit. So we're here. We have just three more levels, and we'll get to Turing complete. So let's start. By the way, hi Nigel, I saw you. Unlurk. Wait, you lurked? So yeah, oh my god, what is this? A program, oh my god. RAM. The instruction input component has been removed. It has been replaced by a program component. Every tick use the counter to load the next instruction from program's memory. Latency is... wow. I mean, I've lagged and dropped a few frames. Maybe that's why. Must use the counter component you unlocked earlier for this level. Yes, I know. Custom, instant custom, notes and counters, 8-bit sync, mass, logic, here, 8-bit counter. So we've now got a program, which I can move by the way. Also, let me... Okay, so now we have a program, which is large. This is our last computer thingy. Now, I probably want counter somewhere here, actually. So it's like overriding of program. I mean, I can use counter, but now, like, what's gonna tick it? 13 seconds. That's a bit. Okay, I'm gonna put it here, fine. I have no idea, to be honest. This program component. Okay. Oh, it works. I guess those are just random instructions they put in to test stuff. Well, that was easy. Now we're one step closer. Immediate values, and then Turing complete, I assume, is gonna do jumps. Conditional jumps and conditionals. Because we need some way of doing it, you know. We need a way to directly move numbers from our program into registers. For this, we use the immediate mode. When two highest bits are zeros. Switch to YouTube again. I'm not seeing bit of chat. I need to do this. So yeah, when in immediate mode, the whole byte is interpreted as a number that we save into register 0. It means we can save any value between 0 and 63. Okay, that's pretty simple. Into register 0. So assuming we're so the first output hijacks. So the first output indicates that we need okay, I'm gonna do an 8-bit switch. I'm gonna do an intersection of the program instruction again. Thank you for the refollow again. Okay, byte thingy. And an on. Now, what do we actually need? We need to move into register 0. For the addition, I think it's register 3. Let me see the instructions. Copy into to register 0 from, I think it's yeah, this is the last one. I give you some sleep. I have slept today. Well, I went to bed at like 1 a.m. and I slept for 8 hours or 9 hours actually. So 1 0 1 1 1 0 0 0. 1 0. I think it's reversed. Oops. Oh, so why are the first two 0? Are the first two? Oops. How do you come back? Level map. Bring me back here. So why are those two enabled? Uh, 0 1 1. For some reason I have it to. Oh wait, it makes sense. You know, I have it in the register 3 error. Okay, so then we have enabled register 0, and the input comes from the. Well, you know what? I might not even enable this. I might remove this. And instead ALU is gonna be enabled by the calculate mode. So it's this one, which is this one. Okay, I'm gonna leave it here. And now this. Actually, you know what? I'm gonna do this. Why is it flipped? Okay, here. So this is enabling ALU into the bus, and then I need to enable. So in this case, I need to enable what? Immediate mode, which is the instruction itself into the bus. So this is a bus, right? I got birds is like loud. So let's just say, yeah, I can't. Hello, chat person. You know, if you want, you can search for Godot at dawn for YouTube. I don't know, maybe it exists. Probably doesn't. And I'm gonna implement it at some point. Okay, so we insert the instruction. This is an 8-bit switch or a 1-bit switch? This is a 1-bit switch. Hold on, I need an 8-bit version. Now we connect the immediate mode here. Also now I wanna move this here like that, I don't know. Okay, I can do this, and this. Okay, now ideally I would. Oh, I can move those things. Yes, I can. It's not important though. So I kind of wanna move this differently, route it like this for some reason. Okay, so this control should work, right? It should work, and it does. Well, I'm kind of proud of myself with about coming up with this, and we've unlocked a new level. Oh my god! So yeah, this thing, like. When we have a special instructions, I'm just overwriting the copy instruction to copy from a special location to the value, to the special output. onwards. Okay. Oh my god. Why? We haven't touched on conditional jumps at all. There is a condition mode. I have no idea, by the way, I have no idea how conditionals are gonna work. Maybe we don't get jumps. I mean, we have counters, so we should, right? Yeah, we should be able to jump to register, like, for example. So yeah. Working computer. Till this point, all possible programs have been confirmed by to running in order byte by byte. Yes, we've got 2 jumps. By the way, how do we... Is there a way we can actually populate a register fully using immediate values? I mean, we can just store them in memory, so... I mean, that's a program memory, so we can't read from there. Good question. Let me think about it. So we have a way to enter immediate value of up to 64. Actually, we can just add it with itself to multiply it by 2 to shift it left 1 bit, and then we shift it left enough times. We enter another one. That's so annoying, you know. If we want to use full jump abilities, that's so annoying to get an address. Before, only code could influence memory. Now memory must influence code. With the addition of conditional logic, our computer can run any algorithm and calculate anything calculatable. Continue. The final thing we need to add is a mechanism for changing a program counter through instructions with certain conditions are met. This is a conditional jump, right? Nice. That's important. We're becoming Turing complete. Today we'll complete this achievement. Also, this bird is so loud. Also, it's cold outside. Anyway, when the 2 largest bits are set, we are in conditional mode. In condition mode, the value in register 3, which is the output for the ALU hard-coded, is compared against the conditions defined by the lowest 3 bits in the instruction. So value is compared against conditions defined by the lowest 3 bits in the instruction. Okay. If the condition is true, we override the counter to the value in register 0. Okay, makes sense. Conditionally changing the counter means we can skip instructions based on conditions or have instructions run in a loop. Yes. So when we have an instruction this mode, we don't care about those 3 bits. So this is a condition. And the result is the register 3, right? Hold on, let me reread this. No. I don't like... This icon doesn't make sense to me. Okay, so so we check register 3. Yeah, we check register 3 against the condition. We have a conditional thingy. Yeah, here it is. Oh my god, it's so broken. I wanna see... Why is it so broken? Hold on. Am I making this... am I making it too small? Something... With schematics. So I wanna go to conditional. I also wanna remove pop6 because it's well, yeah, bad. It's so... I've compressed it so much that it doesn't... that it doesn't even like display properly. Have it just a block here. Why? How do you fix it? I wanna fix it, you know? Do you just put a NOT gate somewhere? Here. Ah! Why is it so weird? So, depending on how I move it, it just places a pixel. Oh my god. Okay, what is the smallest thingy? Off switch. I'm gonna take off switch. I'm gonna take a few of those. So I wanna make it square. This feels weird. Also, those are pretty sure not important. Okay, this one was important. Okay, this is here. I just wanted to look like something. Unless it grabs the wrong one. Where do I put it though? I need to paint this cell. I want to paint the cells. Hey, come back. I mean... Is it gonna paint those? I don't get it. Like, why is it... It's so broken. I mean, the fact that I don't have anything here. I guess I could remove those and it's just gonna be shaped weirdly. But I mean, it's for me. I guess I could move some of those. Also, how is a condition okay, I mean sure, but like now it looks weird. Okay, not. You know what? I'm gonna keep it like this. I'm gonna keep it weird. Because I don't know. Like the shape of it is off. If only text like was here, for example, I don't know. Anyway. So we have our ALU, we have our condition. Condition is checked against register 3. Condition color, let's pick a color. Let's do this one. Like the ALU but condition. So now we check how so we have condition and input. Input is gonna be this, condition is gonna be the instruction. Let me route it here. Now what's it gonna output? Also condition checks I wish I could double click it and see it in component factory. So condition checks first 3 bits. Lowest 3 bits, so it's just instruction, right? Now I just need to store the output. Oh no, I just need to use the output to store it in the program counter. So we're gonna output register 0 for this one. You know, I'm gonna just stretch this. So we're gonna output register 0 for this one. And oh, by the way, what was the last thing we added? Immediate. So I could replace this by colors, but I guess no. So I could do. I could route this here, and also add like. See, I'm gonna add another override here. That's good. Oh, I only had one counter for this level, which is interesting. 8-bit switch. Okay, so we're connecting another one. So this is the last conditional mode. It's gonna override the instruction to output. This is kind of a microcode, you know. If you watched Ben Etter's Breadboard Computer series, which I highly recommend watching, because it's awesome. Yeah. Instruction. So if I wanna copy to whatever, to nothing, to a custom output, I want to copy register 0. Yeah. So it's a bunch of zeros and 3 ones. Okay, this. So I wanna copy it. I think I never actually used this output, right? Yeah, I never actually used this output. So in conditional mode, I'm just gonna set the counter, assuming it's condition. So this thing only outputs 0 whenever it's not. Oh wait, it only outputs 1 when a condition is met and we are in conditional mode, right? Actually, no. So I should put a switch. Like, actually, I should put an AND here, but I'm not gonna do that. Instead, I'm gonna put in a switch. just because. Also, I kind of want to move this one a bit, oops, a bit down, so it's like more packed. So I could actually put a point here. So we're gonna route this here, and now the output is gonna go to, I mean, I can put it into the output bus actually. Oh wait, output bus is oh, this is an input bus. Yeah, I need to route this. Okay, so I'm gonna route this here. So this is set program counter. Also, I should probably use colors for this instead. Color coding is not that well in this. I mean, like, I didn't do a good job of color coding everything. Increment override. So if we enable override, we in this case, and then the value must be the value in the data bus, which I guess I can get from here somewhere. So it's just connected here. So I guess I could route it somehow like this. I don't really like this, I don't really enjoy this. But I mean, we need a data bus somewhere here. So let me actually just do it properly. So I'm gonna route it like this and then up, so that it's always present here. I can use it here. And 6, it should be, next tick the counter value will be 6, it should be 7. If register 3 is less than 0, counter equals 7. Is it enabled? It's not enabled for some reason. So there's okay, the debugging time. Okay, so conditional mode is enabled. 194. What's the instruction? Level input. Instruction is 194. Let me see this. Here. When result is less than 0, copy register 0 to counter. So it should be less than 0 also. I should probably switch this, but doesn't really matter. But registers 3 holds 2, which should be, oh wait, no, register 3 holds -1. Why is it outputting 2? Ah, because this is not register 3. Oh my god. How have I done this? Okay, sure. Now I'm gonna just move this here then. Now it should run. And here we've got our Turing complete computer. You did it. Thought you were just this odd looking hairless ape creature, but you actually built a real computer. Amazing. Unlocks a programmable memory component, and a manual entry on Turing complete. We did it. We've completed the Steam achievement. By the way, I don't have Steam open. I mean, I do have Steam open, but it's just hidden. Please show up. Open Steam. I mean, it's running. So yeah, we've got Turing complete. 21.6% of players have this achievement. Turing the game profile. So 54% of the game complete. I think I'm still not in the leaderboard. Or maybe leaderboard just shows like 4,000 people and I'm not in there or something. Also, leaderboard for some reason always takes a while to load. So yeah, I guess I'm gonna leave it. So yeah, we've completed a major part of it. And now let's actually use our Turing complete computer and program it. Programming. There's not much level in programming because then it comes CPU architecture too, and then functions, and then assembly challenges, which is fun. Yeah, this is gonna be fun, I assume. But let's actually go to programming it. So this thing gives us a manual entry and something else. You have built your computer, but to win the competition you still have to finish the maze. But since you don't know how to program it yet, you're not quite ready for that. So in the meantime we will have you help out on the ship a little. Click on edit memory icon on the program component to start programming your computer. Your computer should read an input, add 5 to it and output it again. No need to worry about overflow. Okay, read an input, add 5 and output it. The immutable red register components have been replaced with custom component with identical functionality, huh? Register plus? What? I wonder what this is, and do I have it in custom? I do have it in custom. Can I edit it? Like the I can edit it. What is that? Oh wait, that's a memory probe. And this is an 8-bit register. Okay, so this is a register. So this is basically just an 8-bit register with load always enabled. Well, actually with custom stuff, and also we have a probe here. Memory probe. Anyway, let's get back to the level. Oops. I wish there was a I just said I wish there was a button to go back to the level, and I think it is actually there. Well, wait, is this back? Yes, it is here. Feel free. Free to change the program of your computer. So I wanted to read the manual entry. On Turing complete. Where is it? Turing complete. Certain computers, like simple calculators, are limited in the algorithms they can perform. They cannot perform any calculations that requires looping or recursing an arbitrary amount of times. Technical machines without looping or recursion can only deal with combinational logic. Turing complete machines, on the other hand, are as powerful as it is possible to be. A Turing complete machine may have a slow CPU, but it is powerful in the sense that there is no computable algorithm that it can't perform. I mean, memory limits as well. And like also electricity limits. Also this thing, I feel like there should be something here, no? I feel like I'm missing a register. Hey, somebody took away my register. Can I rerun the tests on this thing, just in case? I mean, there are no tests, so I guess. Oh my god, binary editor. We're gonna be programming this, and I can. Okay. So let's start with loading from input to register 0. So it's 176. Now, then we're gonna load into register 1. We're gonna load an immediate. Hold on. Immediate. It's instructions. After you complete the level, Turing complete the instruction panel allows you to manually edit instructions. This is only available in your own computers. If you finish the overture computer and see something weird, odds that you may have changed the definition. Each row has a label and 8 bits you can set to either this or this. Instructions panel, the bit pattern matches the row. Okay, so I can edit instructions for the reason I think. Okay, this is a manual entry that's not in here. Where is it? It's not in here. Funny. Okay, so I can edit it. I'm not gonna edit it though. Yeah, I'm not gonna edit it. I wanna see the definition of immediate. in order for me to see that, I can check. So immediate is the first output. It's this one, which is loading into. I think it's loading into register 0. So it's copying into register 0 or from register 0. Resets. Okay. I don't remember. Yeah, I think it's copying into register 0. So it's immediate, it's into register 0. Okay. Since it's copying into register 0, it would make sense that we copy into register 1 here instead, and so immediate is gonna be 1. And then we need to add them together, which I think is gonna put it into register 2 or 3 or something. Oh, so immediate is into register. Adds, it adds into reg 1 and 2, so we need to move the immediate. Oops. Yeah. Also, I can switch back to this. Okay, so here we're moving this into register 1. Then I need to copy register 0, that's immediate, into register 2, so that I can add them together. Then I can add them together. Yeah, assembly language is gonna be really useful, you know. So add puts them into register 3. Now I should be able to output into. So say input, I need to output into output. I'm gonna output register 3. Oh wait, I need to add 5 to the input, but I mean, sure. So enable 4 of those. So here I'm loading 1, I'm just gonna load 5 instead. Okay, now it should work, I think. What a sound effect. It runs pretty slow. But it runs, that's the only thing that matters. We've unlocked code IDE. We've unlocked an IDE inside of this game. Also a manual entry on assembly. Well, that's interesting. Calibrating laser cannons, and it also gives me something. Ownership will naturally shoot incoming asteroids with lasers. In order to calibrate said laser, we want you to calculate the circumference of asteroids using an advanced equation. 2 pi r. R is the input and you can approximate pi as... So I just multiply it by 6, right? Send the answer to output when it has been calculated, and I guess... And now you have access to assembly programming. It allows you to add names for instructions, so you can, for example, type add instead of inputting 68. Okay, what's 2 pi times 1? Also, what is this? This is a screen. Shows the visual of a level in the main campaign. What? That's interesting. They added a screen to my computer. Well, for me actually. And what's link components? What is that? What have I done? What is that? What's link components? I can unlink components. I can link components. Okay. What does this do? I think those are like memory probes or something. No, maybe I can set like register values using it. What files? Oh my god. An actual IDE. Okay. I'm a comment. Below calculates 1 plus 1. So we take 1. So then I meet it. We move register 0 to register 1, register 0 to register 2. I wish they could like have parameters. Also linked components. I don't get what it is. Anyway, we need to so we need to input or actually into reg. Which one we do? We do 1. What's copy? I think it's something like this. 113. We'll check though. Okay, this one actually 177. Yeah, it was close. Copy from input and register 1. So I just switch the copy thingy. Save. Okay, into reg 1. Into reg 1. That is insane. I did not think I would be doing this. So I'm gonna do reg 1 to reg 2. I wish I had like arguments. Ooh, next. So copy register 1 to register 2. Reg 1 to reg 2. Save. I hope they are gonna give me some IDE to like do parameters. Like it would be really useful to have parameters in here. Anyway. So I copy register 1 to register 2. Now I add them together in order to multiply it by 2. And then I'll need to multiply it by 3 as well. Which is how you do it, right? And in order to multiply it by 3, you multiply it by 2 and that's the original, right? So we add them. And then we have register 3. We need to move register 3 to register 1. And register 3 to register 2 and 2 0 as well. So I'm gonna do this. Copy register 3 to register 0, reg 3 to reg 0. So reg 3 to reg 1. I think this is correct. And reg 3 to reg 2. Save. Now we copy that a few times, then we add it, and then we need to add register 0 to register 3. I wish add was actually associative. Can I actually, you know what? I could change the CPU a bit. Also I can do a new program. Wow, that's insane. You know, I can change the CPU and the instruction set, but I feel like it's gonna end not end well. Okay, so yeah, we add this and we do register 3 to register 1, and then we do register 0 to register 3. Oh wait, 2, and then we add it final time, and we do that. What's 2 pi times 8? Is approximately 48. Also, did it? No, it didn't connect the linked components, but Chris. So 48. What have I outputted? 27 for some reason. Okay, so we've messed up somewhere. Okay, I can skip this. 1 into register 1. Okay, can I remove this by the way? So what's 2 pi times 1? Ah. 2 pi times 1 is 6. What have I output? What am I outputting? I'm outputting 3. What? Also, what is this? Okay, so into register 1, then register 1 to register 3, then we sum them. So we multiply the value by 2. Then we copy it 3 times. We multiply it by 2, add the previous value, and then we output it. I think that's gonna work. Yes, this is working. Which is insane. So I am gonna modify the instruction set at some point. Because I want add to be associative. I want to associate it. It's gonna be easier if add could output to the same register it adds to. It's gonna be much easier. And I think it should be register 0 instead. Which is, so we do register 0 and accumulator. Unlocks Robotron 9000 plus. Oh my god, you know what? We're gonna be solving mazes, I think. I think it's gonna be maze time soon. Oh, it's maze time this. It's maze time here. Spatial invasion. Now I wanna know if I get... You know what? Should we risk it? Also, we unlock manual entry and something unknown here. But I think I'm gonna do storage checker first. Storage cracking and masking time first. The security access to door to the storage room is broken and keeps locking our old janitor inside. What does this word mean? One who attends the maintenance or cleaning of a building. Okay, that's what it said. The door keeps changing the passcode. We need a program that can recover the passcode at any time. This way to find the passcode would be to try all combinations until you find the right one. So we're doing a brute force on here. You're kidding me. The broken mechanism does make a weird beep when you guess it's too high. You might be able to use it to your advantage. Wait, are you asking me to do a binary search? No. No output will fail the level. Additionally, the input will be 1 after a guess that was too high and 0 otherwise. Can I do a binary search here? I mean, binary search requires division by 2, and I have no idea how to do that, so sadly, probably no. Because this thing might not be like computable. computable. So we can't actually compute anything, I think. I could do a binary search here, but I can't. Because I don't have division, and I don't know how to divide. What is that? Labels and constants. Also, you actually should take a look at the assembly manual entry. There is an assembly manual entry. Oh, here it is. Okay, I can see stuff. Constants, labels, breakpoints. Okay, but I don't see arguments, sadly. You can use mix of assembly codes and numbers to set bytes. Assembly codes are just synonyms for a bit pattern. For example, instead of typing 196 for add, this code can be named add directly, simplifying reading and writing code. Comments can be added using hash. Additionally, the const keywords can be used to name a value within a specific program. Label assigns a name to the byte offset of the line it was inserted on, especially used for naming jump destinations. You can add, subtract, multiply, integer, divide, modulo. Okay, this is useful. Now, okay, we can actually do arguments here, because I assume this is macro programming. Can get by clicking on the line number. Coins can also be added to any of the linked components, pausing the program when the state is changed. Okay, this is interesting. This can be specified in binary and hex. Okay, this is insane. The fact that I get breakpoints on linked components, that's insane. Also, no signal here because door is closed. The door is locked. I mean, not but... Okay, so I'm gonna risk... I think I'm gonna risk... Okay, how do I can do this instead, right? I'm gonna move this up. Also, this line is gonna be messed up, but I don't care. I'm gonna fix this line later on. So ALU, I'm gonna do 0. Also, this is the wrong color for the ALU operations. I'm gonna add 0 and 1 and store it in 0. And this is the bus, right? I can just do this. Okay, I want beautiful curves here. Also, I want this line to be of the color. So it's this one. This is calculate, right? No, this condition. Oh, what? Yeah, this one. See, I am editing the computer, but I think they are actually not angry about that. I think they actually like, considering that how they said about that I can change instructions, I should be able to edit it just fine. Like, why I didn't really want to do this is because we have also the CPU architecture part 2, and I'm not sure how this is gonna be. Okay, so this is a jump. This is a jump condition. By the way, we have a conditionless jump as well. You know that. Also, this is unlimited, right? I mean, it's huge. I can build whatever I want here. By the way, there is a guy who made a RISC-V computer inside of this and made Rust compile to it. I saw it in project section, Turing complete thingy. Okay, so conditional. We check condition against register 3, which is the output of ALU, which makes sense, but now we don't want to do that because output of ALU is the accumulator register, which is register 0, which means I should move this, up a little bit. Maybe I should move it above. I don't think so though. So I'm gonna do this one. Or like this. Okay, no, I don't like this. I'm gonna do this instead. I want it to look good. Okay, that looks good. Now we need to edit those things. So addition is which one? Yes, I am hacking. I mean, okay, so I should color code this as well, by the way. This would be more useful to color code, I think. So we've got first one is immediate, yes, sure. Second one is calculation. So this one. Oops. I feel like I removed a bit too many of them. Second one is calculation. Third one is copy. Fourth one is the condition thingy. So we do this. Mini particle system in macro quad. I mean, I don't know how hard it is, but that's cool. I guess instance. Does macro quad has any instance thingy? Any instance rendering? Or is there like, is there anything better than instance rendering for those? I mean, you can do geometry shaders, I guess, but they're specific. Okay, I wanna change this. I wanna change so this is the addition line. What is instance rendering? So you don't just send a lot of geometry to the GPU and render it. Instead, you send one piece of geometry, and then you send like instance buffers, and then you run shader. So you run your vertex shader on each instance, and you give it the original mesh that you sent, and then instance data, and it generates each new instance, and so you get a lot of instances from one mesh, which is faster. This is instance rendering. Or are you generating like polygon buffers on the CPU? Or are you doing anything like else? I don't know, pixel software rendering, whatever. Where's instruction? Okay, so copy input register 1. I think actually I don't even need to edit any instructions by the way. It's just like main pages. Condition. So yeah, why can't I program it? Anyway, copy output. So it's copy. Compute unused sub add-on or immediate. Okay, I mean sure. Now I wanna copy. So the ALU copies from, I think, let me enter the original one. I think this is the original. So I'm copying from wherever into register 3. Now I'm gonna copy into register 0. So I just disable those bits. And I think I did it a bit too strongly. Also, since this is conditional. Wait, since this is LU, I might as well do the color. I think it was here. And the copy operation code. So yeah, this then conditional. This is what? This is immediate, right? Immediate is not colored. Conditional. So conditional copies into wherever, into program counter from register 0. Hi, it is already done. Oh wait, register 0 is the CPU buffer. Okay. This is latency. So you're creating a whole mesh on the CPU and then sending it to GPU, right? Okay, so this is a problem. Should I check for conditions in what register? Okay, maybe there was a reason behind it. Conditional. So there's a condition and there's... I mean, I could use those 3 for the register, you know. But should I? Let's copy from register 0. But I mean... So this is, so I have the accumulator. I do ALU operations with it. Maybe condition should check the first one. Yes, I mean, okay. So register is. I mean, we can do immediates into it. What would it actually look like? We wanna jump to label. Jump, and it's gonna be like, so it's gonna be my label, and then jump to it. Unconditionally or conditionally. So we do that. This is like the ideal way. And this loads into register 0, so condition could be checked against register 1. So like if I compare, for example, I do the subtraction, and then I'd like to jump somewhere. I guess I could just do reg 0 to reg 1 and then jump like from register 1. I could jump through comparing any register because I have 3 bits. You know what? I'm gonna do this. I'm gonna do jump from any register. Where's the instruction? Here's the instruction. So I'm gonna also move it here. Also, what is this? Okay, sure. And this and this and this. And the splitter. Okay, now, which of the 3 bits? Condition. So, those. Also, I should color it. So I do 3 bits. Then I do this. Okay, so this is the conditional jump. Yeah, I have modified it. I have modified the system. Also, this could probably be colored as well, because why not at this point. And so this is a condition, right? What would the condition color then? Oh wait, no, this is the instruction line. Okay, I'm just pressing Ctrl S at this point. So now, instructions, I guess I want to edit it now, since, so what instructions do we have here? We have, apart from condition, we have copy. Copy hasn't changed. I'm gonna leave question marks, which is special thingy. Compute. And then immediate. So in the condition, can I like label it? How do you make those things? I wanna create a label. Oh wait, I need to do an... Okay, wait. I thought I could do it in the middle of it. Okay, so those can be any. This is so condition jump register. This is jump register. I'm gonna leave it as address. I'm too lazy to copy all of those. Oh wait, all of those values. I mean, actually, oops. Come back. So those are all conditions, and I think it has a race machine. Oh wait, no, it hasn't. This is the address. I wanna move it. Is it gonna move? Is it sorting stuff? It is sorting stuff. Oh my god. Okay, so that's so we do register 0, register 1, 2, 3, 4, 5, output or input and whatever. So we do register 0, 1, 2, 3, 4, 5, output question mark or input question mark. Register 1, 2, register 3, register 4, register 5. So this is input. Either input clone is there is and then question marks. Now I pressed reset. No, I didn't. I got scared. I think I have pressed reset. Okay, oh my god, I did press reset. Why? Okay, so we do this again. 0, 0, 0. Register 0. 2, 3, 4, 5. Input thing. 1. Register 2. Register 3. Register 4. I hope I'm doing this like not for nothing. Input. Like by this I mean editing the computer. Editing the out venture ISA for my liking. Now, so I can jump there. Great. So I'm gonna do 1 1 0 0 1 1 1 1. So how do I program it? How do we program it? So I'm gonna click link components. I don't know why I need it. Also, this thing doesn't link anymore. Oh wait, that's how I link stuff. I have no idea what link components is really. But okay, so let's add some assembly codes now. Okay, so I'm really liking this game from this point. The fact that I can edit the Outventure CPU and add whatever I want here is insane. Okay, so let's start with immediates. I mean, no reason to start with immediates. Let's start with compute. So compute only takes 3 bits. I mean, I could also use. You know what? I can use those 3 bits for an input, but that's gonna be hard. Okay, I'm gonna leave it for later. But as an idea, those 3 bits can be used as a second input to accumulator, and this would be really useful. Trust me. This would be like x86-ish at this point. And I mean, I don't like x86, but since this is a RISC architecture, reduced instruction set computer, it's good. Anyway, let's do an OR. Let's do an OR first. Compute OR. Save. Then let's do NAND. Save. NOR. And wait, I forgot to change the values. And there are 2 ends. Oh wait, no, what? Hold on. And NOR. I need to fix NOR. NOR should be this one. Save. Now, I kind of want to remove all of those. And so I'm gonna remove all of those. And NAND, NOR, OR. And so there's gonna be add and sub. Add is already there. Sub. Save. Now. Unused and unused. With that, compute is done. So we have copy and condition. Then. So copy. Let's do copy. Copy as an instruction. So like this is gonna be word. Then we're gonna do registers. So we have in and out. Let's do out reg 0. Or let's do 2 reg 0, like that. So 2 register 0, like that. 2 register 1, 2 register 2, 2 register 3. I mean, those are just numbers. So I guess I could skip those steps. Yeah, I'm gonna skip those because 2 are not used that much. Best viewers, go away. I'm having so much fun. I've never had so much fun in my life before. I mean, I guess I had, but that's fun. So I'm gonna do registers like this. And yeah, register 0, register 1. Actually, I'm not gonna do. I'm not gonna do register 0. Or am I? I'm gonna do register 0. Okay, fine. Register 1. So I'm gonna do registers like this because they're used everywhere like this. So register 2. In other instructions. Register 3. So like, out ventures can be so extensible. Register 5. Wait. This. Input. Save. This is special. We're not gonna touch it. Also, I wanna do an output one. So this one. Output. Or can I just do out and instead of input I'm gonna do in. Here. Now, how do we actually write programs with this? Hold on, I forgot about conditions. So conditions do take registers, but they also take the condition. I'm gonna do never. Well, never, I'm not gonna do never. Never 0. I'm gonna do EQ or 0. So I'm gonna do 0, which is 1. Negative. Actually, you know what? I'm gonna do LZ for this one, less than 0. And instead of 0, I'm gonna just do Z. So less than 0, LZ. Less than or equal to 0. Where's LZ? So is it? Make it broken. Okay. So less than 0, less than or equal to 0. Always. Not 0. So this one. Greater than or equal to 0. Okay, and greater than 0. Wait, greater than 0 is this one. Now, we've got a huge number of instructions. Including just the single letter ones, but sure. Now, how do we actually use this? How do we actually program it? So what do we need to do? Recover the passcode. Create a label. Call it loop. Then we're gonna do... Oh my god, I like this. So then we're gonna do what? So we're gonna crack the password. I assume... Okay, I'm gonna load an immediate 0. This is gonna be the counter, which is register 0. Hold on. Actually, like condition. So how did I do conditions? I did condition with register 0 and we jump to a random one. Well, a specified one. I mean, that's not that useful. I could load immediate and okay, so it's better if I jump into 0. Yeah, no, I'm gonna jump into register 0 always, because that's where immediate loads. And condition is gonna be taken from an arbitrary one, from a bus. I know I can do this. So we do condition with a bus. This is the output, right? And we jump immediate 0. This is jump target. Okay, here and here and here. I'm just gonna remove those, and I'm gonna remove this. Okay, now this should theoretically work better. Now, so we go to loop. Oops. So how do I jump actually? Wait. Okay, I forgot about like conditions. So conditions must have those 2 bits set for all of them. Let's quickly do this. Hijacks, welcome back. Copy and always, so this is greater than or equal to 0. Greater than 0. I wish they were sorted by their value instead. So I need to set those. And what I can do, I could rename this to jump. Why? Very depressive. Copy. So if I do JGE, I'm not gonna do 0. Yeah, I'm renaming this again. Greater than JG. Jump greater than. Actually, GT greater than. Jump less than or equal to. GLE. Wait, jump. LE. Less than or equal to 0. Yeah, you can remove that. No, less than 0. Jump LT and remember to enable this. Nend nor NZ. Jump non-zero or non-equal? Not equals. So I'm gonna do jump not equals instead of non-zero. And or nor. Should I do prefixes for all of them? Okay, I mean only for jumps, I guess. So 0 is, I could do GZ or GQ, which is what I'm gonna choose instead. So I did Jenny as well. Yeah. Okay. Now, so I'm gonna do jump to loop. Hold on, recover the passcode. Do I just output it always? Just fine. So take 1. Wait. So I'm gonna jump to loop. So I take 1. I add it to 0. It would be kind of useful if I could load from accumulator anywhere. So I take I can take 1, I can add it. So how does add work? Compute add. It adds oops. it adds 0 and 1. Oops. So I need... where's the problem? So I'm gonna do register 1. I'm gonna do copy into register 1, like that. Copy from register 0, okay. Wait, into 1. No, I didn't. I made the... I've added a few more instructions there. So this is Turing completes the game. Where we build our own computer here, it is Outventure. I have modified it a little bit already because I wanted to... And so yeah, now we're writing programs in assembly that I have modified as well. So we copy register 0 into 1, or I can just do copy into 1. And yeah, I needed bar there, but anyway. So we copy register 0 into 1, into register 1. Then we do... so register 1 is gonna be the counter. We do label loop. We take 1, we add it. Then we copy into register 1. Some kind of error here. Lint? Oh, line 6. Then we output it. Copy register 1 into output. And this should work, right? So this is output, it's just counting up, right? That's right, that's right. Wait, I'm not seeing it, I'm not even seeing it output. Hold on, no, this is a register. Okay, it's not outputting for some reason. It's never outputting. Okay, stop. 1 out of 2. So this thing, output enable. Okay, let me try copy. So what do we have here? We have copy register 1 into out. Copy is 1 0. No, 2 zeros. Turn on stream and go offline and start it again, and again electricity went out. Oh, that's sad. That's really sad. Let's register 1. Now it's 1, and then we copy it into out. 1 1. Yes, exactly. This line. I wish I could use a line in assembly, in binary. Or can I? Okay, breakpoint. Oh my god. I really like the fact that it's just so I really like the fact that it's just one instruction per cycle and one cycle per instruction, and that and it's just simple. But for some reason copy register 1. Oh wait, I need to put a bar in here. Yes. How did it compile? Oh wait, I can put multiple things in one line, that's why. Okay, now it should be outputting here. Should be outputting it here. No, yes it does. You can see it does output periodically. And the ID just got hidden. Continue. So yeah, now we just gotta wait until this becomes 256, because I don't wanna do a binary search here, because I can't divide. I have no idea how to divide. I mean, I guess I can do division using subtraction, but that's so annoying. And I feel like it's gonna take the whole program. I mean, my internet is not that stable, but by the way, why I haven't streamed yesterday, because my internet went out. And like I was investigating. I saw that on the internet cable we didn't have electricity, so I mean, it didn't detect that there's a device on the other end, and it turns out there wasn't a device on the other end because like my internet provider services were just their hardware just decided to not work. And yes, by the way, we've passed first level, now we're just brute forcing the second one. And I mean, I guess I could have done a binary search here. That would have been faster. There's an achievement for that. I might do this. And I can't view achievements. Oh, here's it. By the way, Steam is lagging, as you can see. Anyway, so what do we have here? 3-adder multiply. Oh my god! CPU architecture 2 is gonna have multiplication instructions. That is awesome. Functions, level conditions. Hold on. Okay, so binary counter, complete the counter level. Okay, water world, fast adder. Don't have that yet. So yes, I think there is no achievement. I mean, maybe there is. There is an achievement, maybe. So we've completed this level. I wanna complete it with division. Maybe once we get to further levels, we'll actually get some stuff to do for division. How do we binary search this? Can we binary search a byte? Holy Eleanor. I'm not using Wine. This game is available natively on Steam, but if it wasn't, I would have used Proton, which is based on Wine. Anyway. And I'm not using Wine, like, in my everyday life either. Okay, so I really wanna see if I can easily binary search a binary number, because I'm not sure how to do this. So I guess I set the leftmost bit to 1, and then if it's too big, I set it to 0, and then I repeat. Okay, let's try this. The problem is that I can't set the topmost bit to 1. So the largest immediate I can do is 63, so I need to do 32. Then I'm gonna copy into register 1, add, so this is 64, copy into register 1, and this is 128, and I think that's it. And then we output, copy into out, and then we copy input into register 2, so 2, 1, let's do register 1. Let's do register 2, and then we jump if register 2 is what? If register 2 is so it's 0 when it's less than. So jump equals register. We compare with register 2, and we jump to so it's less than. I need to see the level description again. Passcode will be trial combinations. People and all those broken mechanisms. I mean, they're really trying to make me just do a binary search. When it's too high, so if it's less than or equals to, yes. So we do match 1, we do this, label match 1, and then here we do... Here we need to set this bit to 0. How do we do this? Also, is there any way I can divide by 2? This never happens, right? Yes, we have 32. I add, then I copy this into 2. Const reg 64. So I'm gonna store 64 inside of, let's do register stream. So I'm gonna store some constants. I'm gonna store reg 64, reg 128 inside of 4. I mean, actually, I don't need 128. So I copy this also as the 1. I add, then I copy it into output. So this is 128. 32. Compute 60. So I copy it, then compute 128. Then we output it. Check if too high. Now, if it's 0, which is equals, then we jump into register. Then if register 2, which we copied in input 2, is high, then we jump into match 1, which means, so if it's 0, then it's fine. If it's 1, it's too high, and if it's too high, we need to subtract it. So I just load 0 here. It's fine. Now here I can do what? I can load 64. So copy reg 64 into register 0, obviously. We take this, or actually I can just copy it straight into out. Check for, actually no, I can't. Can I compress it? I want to make this program as small as possible. Copy, add, copy. From scratch solo. First of all, don't use TensorFlow, use PyTorch instead. PyTorch is newer and PyTorch is better. Second of all, I mean, it's possible, but you're gonna waste your whole life. If you set out to do this, which I don't know, PyTorch is pretty good. You should just use that. But if you actually really want to make a TensorFlow alternative from scratch, just don't use it. Don't do it solo. Ask for help. Like, I mean, team with somebody. I don't know. I mean, you can start solo and then grow a team. Whatever. So we do this. Okay, so I need to copy this into 1, compute 64, and store to use later. Now I wanna add. What's the instructions for add? Compute add. Well, this part is unused, so check for 64. So we do the bit with 64, we copy it into 1, then we add it. You use PyTorch for everything. Okay, good. Okay, we copy it to 1 and actually I could not do that, so I could skip. Will be kept in reg 1. Okay, reg 1. Now, so copy it, we multiply it by 2, then we copy it into 1. So we multiply the value by 2, we try it, check if it's too high. Is into Good for Minecraft La Film. Welcome back. Well, I mean, I kinda wanna watch Minecraft movie. People say it's not that bad. People say it's like Mario movie. I kind of liked Mario movie. I mean, so much 128 basically. And I'm just programming binary search here, by the way, if you somehow missed it. Because I want to complete this level with binary search. I'm almost sure this is a hidden achievement because they're hinting me. They really, I feel like that. Anyway, so we check 128. Then we jump to it. If register 2 is 0, else we load 0. Then we check for 64. 64 is already in 1, so we just add it. And then we check it. Wait, copy output. So we copy into output, copy input into 2 again. We left the stream 24 hours, so no, don't do that. Stream 20 hours and sleep for 4 at least. Okay, so we check for 64. Now, if it's 0, then we continue, else I need to subtract. So I need to subtract register 1 from register 0, which is exactly what the sub does. So if it matches, does that look like assembly? Because we don't have parameters. Only thing, so we have, I just see, we have instructions, which are combinations of bits. For example, I do condition, register 1, and like less than or equal to 0. This is conditional jump if register 1 is less than or equal to 0, basically. And how I have implemented this here. So we have, for example, less than or equal to 0, jump less than or equal to, is this. And then I OR it with the register 1, bitwise OR it. Or jump EQ, OR it with the register 1. That's exactly how it's done. Anyway. So when I check for 64, this should theoretically... Now I should check for 32. I hope I'm gonna have enough space. Because since we don't have divisions, I'm just hard coding everything. Match 32, match 32. By the way, if I do multiple labels, I wonder how this works. Anyway. Check for 32. So now... I need to load... So 0 contains 64. I need to load it. Okay, so I'm gonna move it into 1. Copy into register 1. Then I'm gonna do 32. I'm gonna add 32. Copy it into out. Copy in into 2. Sections? You mean comments? Those are just comments which are built in. And comments, labels, and constants are built in. By constants I mean you can do like const by 3, something like that. Built in into Turing complete the game. Now, copy in out. So we have. So we put our current value into register 1. We add 32 to it. Now it's in register 0. And oh my god, this is actually useful. Anyway, so we copy it into output, into input into 2. Then we check for. Then we jump if it's good into match 32. If it's not good, so register 0. So we just copy register 1 into register 0. So if it matches, overthinking. So if it matches, then we check for 16. I really hope I don't run out of program space, but I think we're fine. It should not be built in because that is also a type of instruction, right? Or what? You mean what? So like this IDE basically. By the way, we have more programs. Also, I kind of wanna. I can name it. Binary search labels. Oh, you mean labels. So look, labels are built in. Label just makes a constant with this name that is equal to the index of this byte, of the byte that label is currently at. So check for 16. Copy into 1. Check for 16, add 16, copy into out, copy input, match 16, match 16. Stop overthinking and watching stream. So we jump if register 2 is 0, else we copy register 1 into register 0. Now match 16. We check for 8. Okay, I hope it's gonna fit. By the way, we also are limited to 64 instructions, then jumps won't work, which is really sad. Then jumps are gonna stop working. Check for 16, check for 8. I might just switch to brute force in the last few instructions, just to not like copy it so much. I mean, I guess I could do a loop here. It should make you have to include the string match 32 in the instruction if you... What do you mean? Like, look, here I have match 8. So label match 8 generates a constant with value 30, with value 40. Because the next, if I put the next instruction, it's gonna be 40th byte. And then match 8 is just a byte. So instead, it just puts 40 into this memory location. And then, since this is 40, the immediate value, it's just gonna load into the register 0, and then jump a queue is gonna jump using into this address. Anyway, so match 8 is just the same. Check for 8, check for 4. We're getting close. We're getting close to our value, to our target, and then we're getting close to our limit. And I mean, we have 256 instructions, but we only have 63 immediate values possible. So jumps are gonna break. Match 4, match 4. I wish I could loop it. In order to do a proper loop here, I just need bit shifts. If I had bit shifts, it would have been so much easier. Who's the richest person here? Probably not me. I mean, maybe I am. Anyway, so yeah, if there were bit shifts, it would have been so much easier. But something else I wanted to say. I guess nothing. Oh my god, we're getting closer and closer. 4-2, bit 2, match 2, match 2. A stable drop? Okay. I mean, true. I don't have a stable drop. So check for 1. For the last bit, oh my god, this match 1 won't work anymore. Check for 1. So I add 1. So if this fails, so if this is 1, if this is too high, and I subtract the bit, this is low. Well, anyway, this outputs, this checks for sure with 0, right? Yes, it checks with the last bit set of 0 to 0. Well, you're pretty middle class. Okay, so if this checks both with value with set to 0, so I just copy into 1, add, and then copy into output, and this is done. 59, yeah, 59 bytes. Run. Okay, so binary search didn't work, sadly. Let's put a breakpoint in here. Okay, so 208 seems like a pretty good value, right? You see what do you see? I wish I could like view it at the same time with this thing. So where am I? No, it removes the breakpoint. Okay, let me do a few breakpoints. So we compute 64, then we copy to output. I'm gonna put in copy to output where thing is debugging. Yay. Also, can I rename those? By the way, if output... no, output is not linked. Copy to output. Maybe I could link it actually. Then the last copy to output. So let's run it and see where it stops. So it stops on output of 128 step. The value is 1. The smallest instruction set. It consists of one single instruction, you know? In order to be Turing complete, it's like subtract and branch if less than 0 instruction set. SubQ. A one instruction set computer. SubQ has to be one of the easiest architectures to implement in either software or hardware. So yeah, it's actually enough to have one singular instruction to be Turing complete, but yeah, and it's not even that bad, you know? I don't know, there probably is a C compiler program using macros. So you know, you create a macro, add AB, which consists of sub E, and you just generate an assembly language. You can compile to C. You compile C, I guess, too. SubQC compiler. I'm pretty sure there is a compiler. I mean, C-like language. Basic computer generating high-level SubQ assembly compiler. I mean, it's even an isolang. Wow. It's even an isolang. Okay. Anyway, let's debug. So 128 is too high. No, 2 is 1. Jump equal, it's not gonna jump. So it's gonna 0 this. Then it's gonna add 64. It's gonna copy it into output. This is still too high. It's gonna copy match 64, jump Q sub. Okay, this sub is breaking it. So I need to subtract 64. Okay, hold on. So this is 64, this is 64. Why is sub not working? Is sub broken? Is sub a wrong instruction? This 101. No, it's right, 69. Huh? It should sub 1 from 0. For some reason, hold on, we are on sub right now, and then it's gonna... Oh wait, no. Yes, sub did break. So sub breaks. For some reason. So sub takes 16 and 64. Why is it 16? Because of jumps. I'm so dumb. But yeah, that should be easy to fix, right? I probably should rewrite it all, you know, at this point. So this is 32, we compute 64 will be kept in register 1. We check if too high. Check if the value is too high. Copy it into output, copy in. So I'm gonna copy it into register 3. Actually, you know what? I'm gonna copy this into register 3. No, I'm gonna copy. Okay, I'm gonna copy the value into register 3. So 128. I've outputted that. I'm inputting the value. Now I need to copy it somewhere. So it's either 128 or it's 0. So I copy this into 3, and then I copy this into 3 instead. Now I just copy register 3 into register 0. I add 64, which is still in register 1. Then before this, I'm gonna copy it into register 3 just in case. So if it fails, simulation to use a simulated computer. What is that? Until I got this IDE, I were using a computer simulation to make a computer. Now I'm using a computer simulation to use a what? I'm using a computer simulation to use a simulated computer to make a computer. I mean, actually kinda makes sense, kinda true. Anyway, so we check for 64, we copy it into registers, copy register 3 into register 0, so we load it. We add 64, copy it into output. So we jump a queue, so now we need to reload register 3 and load it, the value into register 3, so register 3 contains the actual value. Now I'm gonna copy register 3 into register 1. I'm gonna add 32, etc. Okay, so here I need to somehow save the value. And we are out of the limit here. Match 2 is like what, 63. Okay, I can't add any more instructions really here. I want to have bit shifts. Should I just add a special bit shift here? By the way, there are 2 unused instructions. Are those bit shifts? Are those bit shifts? I'm telling you, those are bit shifts. I mean, I am spending too much time with this, but I'm just gonna go into ALU. I'm just gonna add a bit shift into there, and I don't care. Those are unused bits inside of the instruction. So the instruction thingy, it just allows me to input some number and see what parts of it represent what parts of the instruction, which is powered by a powerful pattern matching system. Okay, so do I have a bit shift? I don't have a bit shift. I am gonna add a bit shift. Wait, I do have custom schematics here. So I'm gonna add a new schematic called bit shift. So I'm gonna add IO inputs, 8-bit input, outputs, 8-bit output. So I have two. Then I have inputs. Oh my god, it's not gonna. You know what? It's not. It might not work because of. Oh yeah. So bit shift. How do we shift bits? Like that, right? I am gonna do a circular one, cause why not? Or should I not do the circular one? Should I do a circular bit shift or a regular bit shift? I think I'm gonna do this one. So this one is multiplying by 2. Which is bit shift left. Can I rename it? Shift left. In ALU, can I now open the ALU and take the shift left? I can't take a shift left. Ooh. Hold on, but yeah, it has a problem. So we have those 3 bits. Let me go back to the out venture schematic. It's not gonna let me. I think it's not. It looped. Storage cracker. Yeah, I wanna complete this level in a better way. So we have an ALU here. I want to check the instruction. Instruction ALU takes is a compute, so it only checks those 3 bits. Like why it was unused. So we have add and sub. If it's 1, we have add and sub. If this is 1, we have we'll have shifts. Okay, that should not be that hard. So if this one is where do we have adds and subs? This one is add and sub. Yeah, this is so tight, you know. So instead of this, I'm gonna take another multiplexer. This is getting tight. So I'm gonna choose this by default, and then I'm gonna choose shifts. Otherwise. And this is gonna be the second bit. Let's see. So then I shift left. So it computes 2 things. I do a singular shift left. Well, that's a bit cheating, a bit of a cheating. But I guess okay. Like what I really need is the shift right here. So yeah, instead of that, I'm gonna do shift right. Let's just do SHR. I'm just gonna call it SHR. So 1 is not going anywhere. So it's basically just is the division by 2. Because I don't want to recompute the value each time. Okay, now having this in the ALU means that I can shift right. So when the instruction is so all set, for example, they're gonna be shifting right? Oh wait, that's the wrong bits. This. Shift right is outputting 0, right? Because the input is 0. Spot 1 is 16. Yes, it divides by 2. Okay. Now we have our level here. Let's try doing a loop. I'm just gonna do SHR, which is compute. Hold on. So there's unused computes. I think it is marked like actually SHR, shift right. Those are both shift rights by one. But sure, this is temporary, right? Instructions. 71. Save. Now I can SHR. Now I can load 32. Compute 64. Compute 128. So multiplied by 2. Then I multiplied by 2 again. Then a loop. Main a loop. So I have the value in the register 0. I need so I have 128 is the value, and then I need into register 1. Then I need the thing. Loop label loop. So I shift right. Registers. I'm gonna shift right register 1. Shift right actually doesn't take anything, you know. I mean, yeah, it obviously doesn't take anything. It mutates accumulator, I think. Yes. So shift right. So in the loop, inside of the loop, I'm gonna check if too high. Main loop. So I'm gonna copy current bit to reg 1. Then I'm gonna check if it's too high and copy into register 2, register 3 just to save it. Then if register 2 is 0, then it's fine. Label matches. So we just matches. So we jump into matches. Use register 2 is 0. If register 2 is not 0, we subtract. So we need to subtract 1, which is exactly what we need from the value in 0. But we copy reg 3 first. Then here. Oh, and we copy it into reg 3 as well. Now register 3 contains the value here. Now copy register 2, wait, register 1, shift right, copy into register 1, and this is the loop. This is labeled loop, and this is jump to loop. So I shifted right and I have the value, right? I think this should be it, right? Let's check in output this one. Let's see. We output 128. This is the one. It matches. So we subtract it, copy it into register 3, copy register 1, shift right, copy into register 1, that's right, jump to the loop. Load. Where is the instruction pointer? Oh wait, never mind. This is I forgot how jump works here. No, it's weird. 8421000000. Okay, stop. We're not outputting something intermediate, some intermediate step. So let's run to this. So we have a value of 128. This is too high. Okay, it's good. Now we have 64, which I think is also too high. It's not too high. Which is interesting. Okay, so it's not too high. 32. So we have 64, but in the register I don't see any 64s here. I only see 6, which is not right. Where do we copy into 3? Copy into output, copy into 3. Huh. Weird. Let's restart. So here we have 128. Copy it into 3, right? Matches, we do this. We subtract, we copy into 3. Then, so 3 has this, we shift right. Now, we check 64. Oh wait, here, like before jumping to loop, I mean, not before jumping loop. So here I need to load, copy, register 3 into out. So here I'm gonna copy into 1 and copy into 3 as well. So we copy it into out. This should work, right? 432 7 1 0. Okay, it doesn't work, but that's fine. We're gonna debug it. So we do 128. Okay, now it's too big. So we copy register 3, we subtract register 1 from it, which is 0. Now we copy it back into register 3. Now we shift this right and 64, then we jump into loop. Yes, jump. Which outputs register 3, which is 64. Now for some reason register 3 became 0 on this operation. This is not right. It should have been 64 still. Wait, I am... Hold on, no, it's right. It was 0. So I'm gonna load this, and then I'm gonna... So I'm loading register 3. I'm loading register 3, then I'm copying... then I'm adding the thing. I forgot to add it. Then I'm gonna copy it back into register 3, and just for good measure, 16 8 4 2 1 0. Okay, it was 0. 32 16 8 4 2 1 0. Level complete. And sadly it didn't give me anything. I wonder why it was 0 the whole time. I wish it was. I mean, I still believe it is something. I wanna rerun it because I didn't see the values change, right? It's actually just 2 zeros. We're back. Oh, that's weird. I feel like it's not 2 zeros. It's just binary searches. 128, 64, 32, 16, 8, 4. Why is it 0? It is 0. I don't get it. It is 0. It is 0 2 times. 8 4 2 2 2 2 1 0. It completes when I output 0. What? Co 0 copy into out. It's not working. It's like this. Okay, let's bring this back. So I don't know. Sadly, it didn't give me anything for completing it in binary search. It is actually just 0. Okay, I'm disappointed. Author of the game, if you're watching this, why? The last of week is 4 days. What? Oh, the last of our week is 4 days. Our weekdays are named zeros, day 1's day, Tuesday, and 3's day. I hear that some Earthlings numbers their Tuesday incorrectly. What? It doesn't really surprise me. Okay, sure. New Year is coming up and we want you to calculate the weekday of everyone's birthday. What? I will give you the date and you will have to... And all you have to do is return the weekday within 8 ticks. 8 ticks! I have 8 ticks for that. In the style, given the number as an input, you should return the number modulo 4 as a result. This challenge is that you only have 8 ticks to output the desired result. No, you don't need to change your hardware, you just need to figure out the trick to do modulo 4 quickly. I know, obviously. Second day of the week, but on other systems, Monday is the second day of the... Yeah, true. Week starts on Monday again. I actually have Monday as the second day of the week. But sure. You need to change your hardware. Yeah, I know how to do this. But I have changed my hardware. But that doesn't matter. So I need to copy in modulo 2. So I copy it into 1, then I load 5, 6, 7, 8, then I end, and then I copy out, right? That's 4 ticks. Let's go! I mean, it was simple. Now this gives me something and a manual entry. The cargo hull has become infested with space rats. We have looked into your machine up to our advanced... We have hooked your machine up to our advanced robot. Oh my god, we're gonna be controlling a robot. Waiting for electricity, GG. We want you to program it to shoot the space rats with lasers. Whatever. The laser can only shoot when there are no other laser beams already in fight. Check robot page for instructions how to program him. There's a link to that page in the program editor as well. Okay. Oh my god. So yeah, in the editor we can see the screen. Robot controls. Shows the robot. Oh my god. Robot and his surroundings. The robot sees one tile ahead. The name and ID are shown up here. This ID number is also in computers. Is also the computer's input. Wow. Robot controls. I just output it. Right? Robot controls. Use arrow keys to play around. Send output to control robot. So I can... Ah! Oh my god. Oh, so this is the game. What was this game called? Invaders. You died. Okay. So this is Invaders. I have to make an Invaders? Yeah, you're kidding me. Nothing. Okay, so what do I have to do? Shoot a space rat. I mean, No, where's the robot control again? Tab. Use action enter, shoot laser tab. What's use action? I mean, I don't have action here, I guess. Yes, I don't have actions. Tab. Okay, I'm not gonna survive this. Actually, you know what? I might. You know, I might just do this. Like, isn't it gonna work? Okay, so I'm gonna press enter a few times until it comes here. And then I just do this. Exactly, I just do this. Like it's even easier to program. Had I been programmed to do this, this would be... Had I been programmed to do this, I would have completed the level. Okay. Restart, please. Stop. So I want to... I want to see what it actually sees, the ID. $33. Okay, now, what's the initial actions? What are the initial actions? I need to shoot the laser, so I do 5, then I do... Enjoy the moment! So I do 5, I do 1, or actually I do 1, I do 5, and then I do 3. I do 1, copy out, I do 5, copy out, then I... Can I run this? Yes, I can. Then I do loop, label loop, jump into loop. So, can I send you some electricity? I'm afraid it's gonna be too hard to ship. So, if I input, oh my god, it's gonna be hard to input. Like the problem is that I don't have many ticks to do that. So I copy input into register. I just copy input, and if it's 0, if it's 33, 1 kilo of electricity. So I sub input into 1, 33, I sub 33. I hope it's gonna be faster. So then if it's 0, I'm gonna copy it into 1. Then I'm gonna do jump 0, so jump equals. Yeah, I should have renamed jump equals to jump 0. So this is JZ. This is J and Z. So jump 0. Why don't his have battery? They do. Some of them. I mean, you have like uninterruptible power supplies, etc. You can get that somewhere. So we'll copy it into 1. Then we jump if register 1 is 0. We jump to where? To skip. Okay, so only when I output does it change. Okay, that's good, that's fine. No. In skip, I just hang out and enjoy the moment. 3. So I do 3. Copy into out. Now, if I skip, I do 3. Connection. Initial. Yeah, so here loop. Is a thing in front sub 33 shoot. So I'm gonna do shoot, jump to shoot, otherwise jump to loop. So jump to shoot. So before I jump to loop, I enjoy the moment. Red in front. If there is a shoot, it other ones enjoy the moment and repeat. Shoot. Now we shoot it. So shooting is what? 5. 5 is shooting. Oh my god, this is slow. Is there like a turbo mode or anything? I mean, it's simulating so much stuff, so I guess it is slow. But don't worry, we'll get to it soon. This program is also probably not optimal. I mean, it is actually pretty good. You know, you can't get that bad. Also, what's in front of it? Oh, it's a broken box, I think. Debris. Wonder if I can interact with debris. Also, it didn't shoot anybody. The hearts in the top are declaration only. Okay, hold on. I wanna. So if it only works, yeah, it only works if there is no debris. It's easy to fix, I just swap those. So I just shoot first and then I come there. And now nothing is in front of me. Yeah, that's a few instructions. This is a pretty slow computer because of immediate loads and copies. But we're getting to it. That's funny. Cost of living over 5. Approximately 50% of your salary. Wow, that's a lot. I mean, that's a place to live, so... Yes, we've got run fast! We've got turbo mode! Let's go! We've got turbo mode! And we've got a manual entry on the robot. Now I wanna... Hold on. Get me out of here. I don't think I can run fast on this level. No, I can run faster. I can't run faster on this level though, for some reason. Okay, fine, let's go to the maze. I think that's gonna be the last level we complete today, if we even do this. The fabled maze. If you solve it, you win the competition. Let's go. Write an algorithm that gets robot from the start to the exit. This level is hard. You probably want to write down the pseudocode for your algorithm before implementing it. Flute feel. Just kidding. Flat feel. Just kidding. I'm not doing any fancy algorithms. I guess it's just right hand. Tip, remember you can't use immediate values larger than 63. A common mistake is to try to jump to the labels further down than the 63rd byte. Yes, I said that. I know. Oh my god. Look. This is like, this has been in the trailer. I've been waiting to have this. Oh, and also we do coins. We have coins. So I can control the robots. The robot. By the way, we've got... I think I've got a manual entry last time. Binary, bytes, negative numbers, string complete, instructions... No! Remember, we can't store anything. We don't have memory, we don't have random access memory, come on! We only have program memory. And yeah, the fact that we don't have random access memory is a bit... Is it the robot? Laser tab. Okay, so I can play around here. So I have to... Okay, I don't have to interact in order to do stuff. I don't know. I assume it doesn't. I wanna collect all the coins though. So I wanna see what a robot sees when... Okay, it's a door. It's called a door. Can I interact with it? Yeah, I need to interact with the door. Okay. I think maze doesn't change. But I'm not hard coding it. It's not gonna fit, come on. So, right hand. Left and right hand. I'm doing... Yes, this maze is easily solvable by left right hand. So I'm gonna do a right hand. I'm gonna run a whole loop in order to get all the coins. And then I'm gonna do another one. So, by the way, what is this? Hold on, I can see something here. Nothing. No, it's just decoration tiles. I really feel like there's something here. Compress some movements like a loop for that long passage. I guess, but like I'm still gonna do just a regular thing. Wait, can I interact with the coin? I can't interact with the coin, I can only collect them. So yeah, I am still gonna just do the right hand, because that's it. Also, yeah, we don't have that many bytes. Remember, 63 byte limit? After that, jumps don't work anymore. Also, we don't have RAM as well, again. So we don't have stack or functions. By the way, we're gonna get stack and functions, right? Anyway, so here, what do we start with? Let's start with saving something to a first byte. So let's save 0. And there's the reason. So I'm gonna do register. Which one? I'm gonna register 2. Okay. So, why? This is if I can open a door or I can't. For now, I'm gonna ignore it. So I'm gonna do const flag 2. Flag. Actually, no. I'm gonna do flag. If you do right hand, the thing you won't collect all the coins. Exactly, I'm gonna do 2 loops. One loop with collecting and another loop without. So one loop to collect and then another loop to get out. Okay, so loop, label, jump to loop. So, but first I wanna do a right hand rule, a regular right hand. So we turn right first. 2 and 0. So 2, copy into out, check if right is available, or actually try going right. Trying to copy copy input into, I don't know, I'll just copy input. Okay, so if it's non-zero, let's just subtract 1. So I'm gonna copy it into register 1 and then I'm gonna subtract 1 and then jump if 0. Oh, I need to copy it. I'm gonna copy it into 1, jump if 0, reg 1. So I'm gonna do another label. If it's 1, I'm gonna do left, else I'm gonna go forward. So copy 1 into output, go there, and then jump into loop. So I'm checking. Can I do a subroutine? No, I can't do a subroutine. No, I can't jump anywhere. I mean, you know what? I can jump anywhere. I can store a return address. Oh no, I can't store a return address. I don't have program counter store instructions. But I can add that, but I'm not gonna do that because we have a whole chapter length, which is where we're gonna do this anyway. Okay, so try going right. We output 2, then we check if we can go copy. So I need to check quickly if it's 1. Okay, let me check. It says coin is 8. So for a door we'll have a special. Yeah, door is 3. Okay. So now those numbers are not just random numbers. Those are useful. We can at least look at the last bit. So what we can do here? Copy. Okay, label loop. So let's just turn right, and then we're gonna spin counterclockwise. Actually, no, let's turn left. I'm gonna do left hand, and then we're gonna spin clockwise. So let's turn left, label spin, then we spin clockwise. Check if we can go there. So I'm gonna copy input into 1. I'm gonna do 1. I'm gonna do end. Copy this into 1. Yeah, that's annoying. Then spin. We're gonna spin if we can't. Actually go there. So we go and then we jump into loop. Something like this. Oh wait, something's not right. Go there. It doesn't go there. Oh, it jumps 0. It always jumps 0. If it's not 0, then we spin. Hold on. So go there and then loop. So it jumps to loop. Yeah, graphics are a bit messed up. We copy 0 to output. Yes. We check it. We can't spin. Okay, so we need to spin right, unless we come from here. So we need to, if we can, go. Let's just do go and jump 0, and this is gonna be label go. If we can't, we're gonna jump to spin. Spin if we can't. So if we can't, we're gonna jump to spin, but before that we're gonna output turn right. So the spin itself. So this is okay, let's do 10 kilohertz thingy. So it does collect a few coins and it loops around because, well, I didn't get the door. I don't have the door logic yet set up. So it's gonna loop indefinitely. I'm gonna keep this, you know, keep this running as a screensaver. So now, if I see the door, I need to do the I need to check the door for the door. Okay, so you know what? So I copy this copy. It stopped. Register 1 into 2 as well. Then I'm gonna sub 1. So if we can't spin, if we can't. Actually, no, it's gonna be end still. So if we can't, then spin. But here, I need to check for the door. Or where do I actually check for the door? You know what? I can check for the door in front of it. I mean, literally. Hold on, is it still running? Yeah, it still works. Okay, so what can I do here? Check if we can go. Copy in 1. So I am gonna check. I'm gonna check for 3, which I think door is 3. 3 sub. Check for door. Spin clockwise. For the door, we have separate. We'll have separate code. Can't spin if we can't. If we can't. If we can, we go. Else we spin. Go. Yeah, it's a bit messy. So check for the door. If it's 0. If it's not 0, no door. So if it is 0, then I need to check for the 2. Jump. Hold on, I'm doing wrong jumps. Sub copy this into 2, into 3, register 3. So then I'm gonna okay, so check for the door if no door. So if register 2, if if register 2 is 0, then we jump to no door immediately. Okay. So check for the door. We jump to no door if this is 0, else subcopy into 3. So if it's not a door, we go. If it is a door, we copy 1 into 2. Hold on. Okay, this doesn't work. So I check for the door. Is a door. So if there is a door, then I copy 1 into 2. So I need to check 2. If register 2, if register 2 is 0, then so if register 2 is 0, then I need to collect all the so then then I need to continue collecting coins. So there is a door. So if it's 0, then I continue, label continue. So if there is a door, so there is a door, continue collecting. So if continue, I do this. Otherwise, I shouldn't continue collecting, I should just use the door. So it's, what is the use? Use action 4. So do 4, copy to out, run. Stop, run at 10 kilohertz. So this should theoretically, we should observe a change somewhere here, I think. And we didn't. So I guess it's gonna continue then infinitely. No, it did! It completed it! Oh my god, we have more levels! Where is the value? I'm not seeing it. I'm not seeing the register 2 here for some reason. Huh? I wonder why I'm not seeing register 2. There are 8 mazes. Okay, hold on. Sorry, I had to stop it, but I wanna see the value. Or is it not gonna work? Is it not gonna... I mean, no, it's updating display. Okay, interesting. So am I not having linked components? So register which one? Which one are we using here? Register 2. 0, 1, 2. This one. It is 2. It is the linked component number 2. Yeah, I'm not gonna do breakpoint on this. So this is 0, right? Huh. I can pause, it's not gonna show anything else. And I think coins are just increasing and increasing and increasing. Because nobody resets this. I think. So for some reason I don't see number 1 in register 2, which it should be there. Register 2. Huh? Who knows? Maybe if I step a few times. I mean, it works, that's the only thing that matters, right? For some reason it's not displaying. You know, but maybe if I actually run it slowly, then I'm gonna see it. Would make sense. Yeah, I guess. Anyway, let's just watch it. I can increase this number. 100 kilohertz. I think it's not gonna be faster because it's one. It can't run at 1 megahertz because my CPU is not that fast. But yeah, let's watch it. Oh my god. I wonder what's gonna happen. Maybe there's more to those mazes. Thank you for the refall, Nigel. Okay, maze number 3 out of 8. Let's see. Imagine it's just not gonna be right hand accessible at some point. The sounds are very familiar. I mean, coins, SFXR. Yay. This is pleasing to watch. 5 out of 8. Come on, let's go. Let's do this. I hope no. I mean, it could be, but I know the developer of this game is not gonna be that crazy. We don't have memory, we can't implement any faster pathfinding algorithm. First of all. Second of all, we still need to search for everything for coins. So yeah, it's not gonna be that. But oh my god, and we fit into what? 28 bytes! That's so cool. Look, it's running there. It's running on this monstrosity, which I think shouldn't be really updating. And that's the last maze, guys. We're here, we're seeing it. It's gonna loop around one more time, and we're gonna see it complete the last maze in the Turing complete game. That's another big milestone. Wow. Let's go. We won the competition. An amazing achievement. 28 bytes of code. If you choose to go through the rest of the levels, I will teach you about RAM, random access memory, the stack and function calls you will get to solve more interesting challenges like this one. But this would have to build a better computer. Overture was a good as a first machine, but it is clumsy and programs get very messy. True. But I modified it. I modded it. To solve those challenges I have for you without pulling all your hair out, you'll need something more expressive. The leg architecture. Well, I actually really like the name Overture. On the other hand, you could also retire, be proud, and enjoy your reward of not being eaten. No, I am gonna continue, but... See, are we building a new computer? Are we building a new computer? XOR and bytecode. I wonder if we're building... Yes, we are building a new computer because the schematic is called Overture. Oh my god. We've ended this. Basically. We've completed the first half of the game. Amazing 28 bytes. Today we've completed 2 major achievements. Actually 3 major achievements. We've got Turing complete. Well, that's 1. We've modified the computer and wrote a binary search. Here. Yeah, here. That's 2. And then we solved the maze. That's 3. Oh my god. So yeah. Isn't it gonna be fun? Yes, I had a lot. If we check out the code. So I'm using register 2, register 1 and register 3 for the temporary values. That's it. Register 4, 5 and 6. Is 6 a register? So registers 4 and 5 for sure. Yeah, registers 4 and 5 were free. So I had registers to spare. What? You wanna put whatever flute field they diff depth first what am I saying? Depth first search queue in there, huh? Yeah, it was fun. See, I think we're gonna be ending there, cause we have to leave this for another time. We're gonna be building a better computer, right? I wonder what leg stands for. Leg ISA. I wonder if it's if it's an actual ISA. Instruction set architecture. Leg V8, huh? The step count, and after a safe estimate of the worst case number of steps, just change a step. You mean like every 500 steps? Wait, 500 won't fit. You mean like every 128 steps I just do a wrong turn? I mean, yes, that could save me from a loop. And actually, when I was at Micro Mouse competition, we were discussing like right, left and right hand, how you could improve them in order to not write a proper algorithm but still beat complex mazes. And we actually thought of the same thing. No, I can't combine two registers because I can't have immediate values greater than 63. So I must use second register in order to check for the value either way. So no, not 16,000 steps. Anyway, I wonder what leg 8 is. Leg V8 is. Graphical Microarchitecture Simulator. ARM, it's official ARM. A subset of ARM V8 ISA. And now available on GitHub. The ISA simulator is a browser-based simulator for a subset of ARM architectures known as leg V8. Is this what we're gonna be building? If we're building a subset of ARM V8, I'm gonna be just... of ARM V8A, I'm just gonna be blown away, but that's probably not true. Add x9, x21, x9, depend labels, instructions and conditional branch, instruction conditional branch label, etc. Reach to statement with label, sub instruction for making decisions. That's a pretty simple lecture. Anyway, I'm not gonna. We're gonna be ending here 3 hours. I said I'm gonna be streaming for longer. Now here you go, 3 hours. I will see you tomorrow, I guess. Let me actually. Let's actually exit. Ow, legs. It lags when I exit a lot. So I want to check it. Quickly check achievement. So we've got 3-adder multiply, tutorial complete, condition 10, using only 10 blue components. Wait, oh, he's live, huh? This level called conditions. Hold on, condition 10, I want to see condition 10. Complete the robot race. Robot race is, we haven't got to robot race yet, I think. And 3 hidden achievements. Boy, okay. I think I'm not even following them. So yeah, we're gonna be figuring it all out later. I think I'm gonna do all the achievements after I finish functions chapter. And there's like another games chapter, but still. So you want a QV boy. QV boy. 74 viewers, you're kidding me. Okay, as you wish. So thanks everyone for joining. It was fun. It was really fun doing this. And yeah. Also, what is this? I remember it was melons. some point. And yeah, I will hopefully see you tomorrow, something like that, or maybe Monday. Probably either tomorrow or Monday. So, and yeah, goodbye.